we got you. Wherever you want to from, we got what you need. Don't get online class, we got you.
Good day, everyone. Once again, you are welcome to Toydel online class. Just as I've introduced the set of numbers, so the first set of numbers, the first set of numbers are called the natural numbers. The natural numbers. So denoted, this one is denoted as n, as we have it on the board. Good day, viewers all over the world. You are welcome to Toydel online class. So today we want to look at implicit differentiation. Implicit differentiation. Now I have about 5 videos on differentiation, and all the five videos are actually talking about explicit differentiation. That is, most of the time we say y is equal to maybe 2x squared plus 3x plus 4. In this case now, y is at the left hand side, then dependent variable, the independent variable, they are the right hand side. In this case now, this is explicit. The functions here, y and x, they are being explicit here. But when you're talking about implicit differentiation, is when we have the mixture of both dependent and independent variable in a particular problem. Then how do we solve such problem? That is what we are about to discuss here. So if when we have an implicit differentiation, both dependent and independent variable will be together. So how do we solve such problem? That is what we are about to discuss here. So let's see example on this. I want to use example to explain. Let's example 1. The question is given that x squared plus y squared is equal to 4. So the question now says find the y, the x. Look at, in this case now, we have both the dependent, y is dependent variable, yx is independent variable. We have them together. In this case now, we have x squared plus y squared is equal to 4. And we want to find the y ds. So how do we get the y ds? This is what we do. Because most of the time we say y is a function of x. So that function could be any function. There are about 6 different type of functions that we'll consider. So if y is equal to 2x squared, what is the y ds? The y ds will be, we bring down to 2x. Okay. Now let's see when we differentiate y, what will be the implication? So here we go. If we differentiate x squared, we are going to have 2x plus. If we now differentiate y squared, we are going to have 2y. Then there will be additional y dx is equal to, when we differentiate the constant, is 0. Please, let's look at when we differentiate independent variable, we just differentiate straight away. But whenever we differentiate, y is dependent variable. Whenever we differentiate dependent variable, in this case now, y squared will be 2y. We have to add the y dx to it, because this is dependent variable and this is independent variable. So in this case now, we just say 2y dy dx is equal to minus 2x. Initially this is 2x. By the time this 2x crosses this equality sign, the sign will change. Then divide both sides by 2y. We divide both sides by 2y. This will take care of this. At the end of the day, therefore, dy dx, then 2 will cancel 2, is equal to minus x all over y. And that's what we are going to get. So this is example under implicit differentiation. Differentiation in which the 2 variables can be together. We are going to take about 3 examples. Let's take another example. Under implicit differentiation and see the implication. Let's see another example. Let's say given that x cubed plus y cubed is equal to 27xy. Find the y dx. So the same thing is applicable here. We just say x cubed plus y cubed is equal to 27x cubed xy. So if I differentiate 3x x cubed, I'm going to have 3x squared. Of course, normal way of differentiating. I have videos on differentiation from the first principle, how to differentiate. Plus, if we differentiate 3y cube, it's going to give us 3y squared dy dx. Whenever we are differentiating dependent variable y, after the differentiation, we add dy dx with. Now, the right hand side. The right hand side is a product of two values, x and y. So this actually comes up under the derivative of a product or product rule. So I want to divide this into two now. I'll divide this into two. 27 is one part. That is, I want to divide it to 27x multiplied by y. So if I want to apply product rule now, when I pick this first one, I'm going to differentiate this. That is, if I pick 27x, I will differentiate y. That is, I'm going to have 27x dy dx. That's the derivative of this. Plus, I will now pick y. I will differentiate 27x. 27x will be 27. That's 27y. And that is what we are going to have there. Please, let's look at it very well. We have the product of x and y here. 27xy. So I try to split it into two. 27x as u. Just view it as u. Then y as v. Under product rule, when we have product of two functions, u and v, the derivative will be u. You pick the first one, dv dx, plus the second one, v du dx. And that's what I've applied there. I've applied the knowledge of product rule to be able to differentiate 27xy. But having in mind that whenever I differentiate y, I will put dy dx at the back of it. So in this case now, when I pick 27x, I differentiate y, which is dy dx. Differentiation of y is 1, then I put dy dx to it. Plus, I now pick y, I differentiate 27x, and that's what I have here. So we now collect like terms now. That is, we have 3y squared dy dx. I can bring in minus 27x there. I will have minus, by the time it crosses 27x dy dx is equal to 27y. I will now take 3x squared to the other side. That will be minus 3x squared. So I can collect the like terms here. Dy dx. What do I have in the bracket? That will be 3y squared minus 27x is equal to 27y minus 3x squared. So from there, I'm going to make dy dx the substitute formula. So dy dx will now be 27y minus 3x squared divided by 3y squared minus 27x. Then 3 is common. 3 is common. I can bring out 3. From there, I can start to bring out 3. 3 is common. At the numerator, I will have 9y minus x squared all over the denominator. If I bring out 3, I will have y squared minus 9x. That's what I'm going to get. So 3 will cancel 3. Finally, dy dx will now be 9y minus x squared all over y squared minus 9y. And that's what we are going to get. That is what we are going to get. So I'm going to take one more example under implicit differentiation. That will be example 3 before we close the class. So I will take the third example. Let's take another example under implicit differentiation. So the question says, given that x squared y squared minus 3xy plus 4xy cube is equal to 4. Find the y, the x. That is, this is what we are given. Product of x squared and y squared minus 3xy plus 4xy cube is equal to 4. So we have, in this case now, we have to be very careful. We have to be very careful and look at the question very well. So in this case now, each of these at the left-hand side is a product of two functions. I might decide to split it into two. Let's split this into two. We split this into two. So we now apply product rule in each of these for us to be able to find the derivative. And that is what we are going to do. So now let's go. If I differentiate x squared, I'm going to have 2x. Then I'll come here and pick what I have here. When I differentiate one, I've differentiated this. I'll pick y squared. Plus, I'll come back and pick this. I've differentiated this. I pick this. I'll come back and pick this, and I'll differentiate this. Please, I want us to look at it very well. When I differentiate this, I pick this. I will not differentiate this. I'll pick this. When I differentiate x square, I have 2x. Then that is when you have u dv dx plus v du dx. That's the knowledge of product. I'm applying the knowledge of product rule here. When I pick the first one, I'll differentiate the second one. When I now pick the second one, I'll differentiate the first one. So I've differentiated the first one, I pick the second one. I'll not differentiate this, I'll pick this. If I now differentiate 2y squared to be 2y, then I'm going to have 2x squared y squared dy dx minus, minus is controlling everything here. So I want to pick 3x now. When I pick 3x, I'll differentiate y. That will be dy dx. Plus, if I now pick y, I'll differentiate 3x. 3x will be 3. That will be plus 3y. I've done the differentiation of the second one. Then plus, I'll come to this place. If I pick 4x, I'm going to differentiate this. If I pick 4x, I'll differentiate 3y cube. Y cube will be 3y squared dy dx. So I'm going to have 3y squared multiplied by, no, let me write it this way. When I pick this, I pick 4x, I will differentiate 3y, that will be multiplied by 3y squared dy dx. So I pick this, I differentiate this. If I now pick this now, I will differentiate this. Plus, if I now pick y cube, when I differentiate 4x, I'm going to get 4. That will be 4y squared. It's equal to differentiation of a constant is 0. And that is what we are going to get. So I can go ahead and write this neatly. That is, I will have 2sy squared plus 2x squared y squared dy dx. The minus will control everything here. Minus 3x dy dx minus 3y. Then here I'm going to have plus 4 times 3, 12x y squared dy dx plus 4y squared is equal to 0. And that is what I'm going to get. So let's look at it very well. So I'll now collect like times everything with dy dx, I put them together. That is, I'm going to have dy dx here into bracket 2x squared y squared minus 3x then plus 12xy squared. So let me take the ones without dy dx to the other side. Will now be equal to, I will take all this one that doesn't have dy dx to the other side. I will now have, this is minus 3y. I will have 3y. Then this will be minus 2xy squared minus 4y squared. So from there, I can make dy subject formula. Dy dx will now be equal to 3y minus 2xy squared minus 4y squared all over 2x squared y squared minus 3x plus 12x y squared. And that is what we are going to get. And that's what we have done. So under implicit differentiation, the knowledge of the product rule will actually come into place. So we should note that. So I would love to stop here because of our time. If you have any further question on implicit differentiation, you can just write at the comment section. I promise to attend to it. Then I would also want to advise that you check all my videos on differentiation so that you'll be able to have proper understanding about this implicit differentiation. Thank you, and God bless you all.